And because I'm going to record this today. So we did examples 1A, B, and C in here yesterday. So let me put those up here. And then I want you guys to work on example 2. Okay, so while I'm doing this and kind of talking to myself so it's on the recording, go ahead and do example 2. And our goal today is to really try to figure out how to integrate. We might not be right the first time or the second time, but we keep on going. Oh, so Morgan, you were here. I can talk to you, so I'm not talking to myself. I know you were looking at this already, right? So example 1 fit into a formula we learned last week, which was arctan. And in this case, the 4 can go out in front. And this formula, a squared plus u squared, or u squared plus a squared, works out to be 1 over a arctan u over a plus c. And I put it in terms of x. Part B, we decided yesterday that that was just going to be a straight old u substitution problem, and it worked out nice that way. We talked about removing the absolute values because x squared plus 9 is always going to be positive. But if you didn't remove them, that's okay too. And then C was probably the hardest one yesterday. And on C, this one we use long division. And what we want to recognize, and I guess this can apply to everyone because I want to show you something I did not show you yesterday on C. When we did the long division and rewrote it a different way, we were able to get the answer. What we sometimes forget is when the degrees are the same, you can do long division. It's not just when the degree of the numerator is more than the degree of the denominator. But anyone that would have tried u sub with a twist on that one, it wouldn't have worked out. So this was a case where I was telling you, division is probably the best option because there will be some cases of u sub with a twist that won't work. Mr. Clark in Calc 2 will call that u sub transformation, okay, so that you know that that's what he'll call this. But it would not work out because x squared, we can't get it in terms of u without a positive and negative square root, and then that gets a little crazy. So that's why this worked out well, okay? All right, so example 2, you're looking at it. What do you think? Give me some ideas. They might not be right the first time. That's okay. Split the fraction up. Okay. Anyone else have an idea? Yeah, Brandon?
For the top, can you do a minus 3 and then a plus 3 and then do the integral of 0 to 1 of x divided by square root of 4 minus x squared plus the integral of 0 to 1 of 3 over 4 minus x squared?
Okay, so if you add 3 and subtract 3, why are you trying to get the minus 3 over by itself? Because then you have x plus 6. Is there any reason why adding 3 and negative 3? I mean, because that's an okay thing to do. Is it just going to get us any further?
Or yeah, I basically split up the fraction in a more complicated way than what it is.
Okay. So splitting up the fraction is probably something we might try, right? And we might have to add and subtract. That's a trick that we definitely want to know, okay? So let's split up the fraction on this one. If you split up the fraction, how will the first one possibly work? How will that first one work, Amy?
It could work with u sub if you multiply by -2 and then balance with a -1/2.
Perfect. Yep, that one will work with u sub if we balance with a -2, multiply by -1/2. Great. What about the second one? How's that one going to work out if we split it up? Arc sine. Okay, so go ahead and work through that one. Now, there are a couple things on this one as you're working through. If you just check to make sure you're doing, like, if you change things to u's, those limits are tied to x's, so you want to make sure that you put the x equals. This one was really important to separate. Okay, so work on through that one. So I think the hardest part is figuring out at the beginning what to do.
Can you do it?
I can work it something.
Yeah. Did I confuse you? Today was like a prime day. I should have really got you. You shouldn't. I confused you.
Wait, why weren't you there? Why weren't you there?
I had to take my car this morning. They had to drop me off.
Yeah, okay.
Okay, how's this one going? Is it working out all right? Now, once you get down to that arc sine of 1/2, we have to figure out what angle has a sine that's 1/2 that's in either quadrant 1 or 4. That was pi over 6. Arc sine is 0, 0. Did you get negative root 3 plus 2 plus pi over 2? All right, so as you finish that one, if you're finished, go ahead and save them with 3. We're really trying to look at them and get some ideas as to how we might start them. We might not be right the first time, but we'll get it eventually. Questions so far? All right. Oh, okay, yeah. Yeah, an arc tangent works without the square root anyway, so the arc sine is the square root. Yeah. Okay. Yep. We did A, B, and C yesterday. Okay. Some of you that were absent. So if you were absent, we went through and did 1 A, B, and C yesterday, and then I did have those solutions up. I put them on today's recording. Any problems? You're doing okay on this one? Okay, so ideas for example 3. And if we're going to take those in just a minute, so you can look even, if you know what to start, you can look at example 4 and see if you know what we're going to do here. Okay, any ideas on example 3? What would you probably try to start with? And what do we normally try to start with? U sub. So if we can algebraically simplify it, we try to go for U sub. Can you tell me why U sub doesn't work on example 3?
Because we left with 6x to the 5th, and that's what it is.
Yeah, we'd need negative 6x to the 5th, and we don't have that, okay? So we need to come up with something else. Anyone have a something else that we might try?
The arc sine.
The arc sine. If we did the arc sine, so and how we would kind of jump to the arc sine is there's a square root in the denominator, okay? And there's an a squared minus, what would u be? X cubed. Good, because isn't x cubed squared x to the 6th?
Mm-hmm.
Then what would du be?
3x.
3x squared dx.
And then balance with the 1/3.
Balance with a 1/3, and then throw it into that arc sine formula. Yeah, good. So it's kind of process of elimination as to some of the ways we think they might work, and then figuring out how they do actually end up working. So go ahead and try the next one and see if you can think about how we're gonna do that one. All right, so any ideas for this one? Cool, this one's the toughest of the bunch, I will tell you that. So arctangent is something we probably would try. Now, if we do arctangent, what's the u going to be? The square root of e to the x, and then we're going to need a, if we take the derivative of that, yeah, so that's where I would have gone too, because u sub we know isn't going to work. And so I probably would have tried arctangent, and that doesn't work. So we need a trick. Anyone have an idea of what we could do? We need an e to the x in the top, right? If we want to use u sub, or if we want to use arctan.
Could you multiply by like e to the x over e to the x, and that's just 1?
Yeah, if you multiply by e to the negative x over e to the negative x, that will work on this one. It's a little bit complicated with the simplifying, but that's something we're allowed to do. So we want to add that to our tricks. We're allowed to multiply by the same thing over the same thing. Okay, so if you did this with e to the negative x over e to the negative x, that's one way we could do it. Anything else that we can think about on how to get, because he's thinking, how do we get an e to the x in the top? What did we do when we needed a 6 in the top? We needed 2x plus 6. We added 6 in, subtracted 6.
That's
So
what I
this-
was trying to do on the other
Yes.
one, and then I split it up.
Yes, that's what you were trying to do on the other one. I just wanted to show you that you're allowed to do those with variables as well, because we've only seen numbers up to this point. We're allowed to do that with e to the x or a variable, because did we really do anything?
No.
No, but do you see how we could split it up now?
And the integral
Yeah. Do you see this 1 plus e to the x?
of the 1 plus e to the x, which is
Yeah. So
which is
this
x.
one is probably out of the bunch we're going to do today the trickiest, because we were pulling another trick out of that bag that maybe we didn't know was in there. Okay, so now we're integrating 1. We definitely want to separate it because 1's going to be real easy to integrate, whereas this one takes a little bit more work. What are we looking at in terms of doing the second one? Just plain old u sub, right? So u is the whole denominator. So du is just that numerator, right? So the integral of du over u is ln absolute value 1 plus e to the x plus c. Could we eliminate the absolute values? If we're not sure, keep them in. But 1 plus e to the x is always going to be positive. Yep, so we could eliminate them if we want. Okay, any questions there? So that was the toughest one today. But try the next one and see if you have an idea. Yeah. No.
So just to be safe, you always
Right. I could see a question where they might say something like, let's say they have a domain restriction somehow at the beginning, not dealing with ln, but x is greater than 0, and you had an absolute value of x and you didn't take them away. They could take off a point because of that restriction that was given. Okay, so they could do things like that. But if it's free response and they don't, you can leave it either way if you want to. Mm-hmm.
I do that because I just want to.
Now this one looks pretty bad, doesn't it? What if you let u be cotangent? Is it going to work?
No.
No. What if u is sine? Nope, you got too much stuff left over and we have an ln of u and we don't know how to integrate that. So what are we going to let u be? Ln of sine of x, and we're just going to hope that works out. So you have to try something, and as you try some of those, you might write them down, you might do them in your head. Like I was thinking if I let it be sine, I'd be just a cosine, and I have too much stuff left over. Okay? So you might not be right with the first way you think of, but try something else. That's why persistence on these is so important. What's du turn out to be? Cotangent x dx. We have it.
And then
So-
it's cotangent of cotangent.
Yeah, we're just integrating u du. Now this one looks a little bit strange when we put it back in, lots of parentheses, but it's the ln of the sine of x, that quantity squared, over 2 plus e. Okay, questions on that one? Yeah?
Are you allowed to put the square and leave the element inside?
You can. I've seen the ln to the 2, just like with trig functions, you just don't want it on the sine of x. Yep, that would be fine. Any questions there? All right, so what about this one? Is this our last one? I think so, and then we're going to talk about all the tricks. Okay, think of our integrals. We have a couple integrals that we can integrate when they're squared, right? Trig functions that we can integrate when they're squared. Which ones? Secant squared and cosecant squared. We can't integrate tangent squared, so we got to do something with it. What is that something?
You can change it to 1 minus secant squared.
Yeah, because we have this identity that you just were quizzed on, right? 1 plus tan squared is secant squared. You can change this angle to anything as long as they match. So we could make it 1 plus tangent squared 2x equals secant squared of 2x. So then what could we change tangent squared of 2x to be? Secant squared of 2x minus 1. Then what? Something important we want to do before we just go to integrating. Are we going to need a u sub on the first part? Yeah, on the second one? No, so you have to split it up, whether you do it and write them in separate integrals, or if you didn't write them in separate integrals, if you did this. Secant squared 2x dx minus, and just integrate that one. So you could either break it into integral secant squared 2x dx minus integral of 1 dx, or integrate this one and be done with it. Because you don't want to keep it all together and then use a u, because then they would expect you to put minus 1 in terms of u, and then that gets very difficult or impossible, okay? So then what is the integral of secant squared of 2x? Not the ln, that's just the plain old secant when it's ln. It's the integral of secant squared. Tangent, yeah, okay. So integral of secant squared is tangent, but what do we have to do here? Multiply by 2, balance with a 1/2. So the integral of secant squared u du is tangent of 2x. Any questions there? Okay, so we've seen quite a variety. So what we're going to do is just review all those little tricks that we either did, or there's one trick that you'll do in your homework, so I want to tell you about it. So one trick is expand the numerator. So if you had something squared, a quantity squared, and you couldn't use u sub, just FOIL it, okay? Separate the numerator, i.e. monomial division, right? Complete the square. That typically occurs in the denominator, right? Both of the ones that we saw where we needed to complete the square, we did that in the denominator. So examples from homework, if you saw this first one, what would you do? I don't know if it's 29. What would you do? Thanks. Expand it. And the second one, what would you do? Well, if you tried u sub, complete the square. Yeah, I'd try u sub first and then eliminate it and then complete the square. Good. Divide improper fractions, so we saw that, and rewrite it in a different form. Add and subtract something in the numerator, so we saw that as well. Use trig identities, we just saw that one. The only one we haven't seen is number 7. Another thing you can do, specifically when you have like a trig function, maybe in the denominator, that's a binomial, you could multiply by its conjugate. You remember what a conjugate is? So it's just change the middle sign. So 1 plus sine x, if you multiply by 1 minus sine x, then you can probably use some Pythagorean identities that you were quizzed on today. Okay? Any questions? One of the things you can't do, we've been doing monomial division so much and separating the numerators, you can't do that to the denominators. And if you're ever questioning, can I do something, like you're in a problem and you're like, oh, is this an algebra rule? Try numbers. 1 over 4 plus 2 isn't equal to a fourth plus a half. Okay, so try it with numbers. If it doesn't work for numbers, it doesn't work. You just want to throw it in there, thanks. Doesn't work for variables, okay, because they represent numbers. Any questions there? Okay, look at this cool thing that's in your book. Now, why would you not just want to take a picture of what's in the book and throw that in your cheat sheets? Yeah, you remember it more and you study and practice. Your brain and your hand, there's a connection. So when you're writing them down, it's forcing you to kind of work on them. You do not have to know number 20, but if you want to know one spot where all of the integrals that we know right now, it's in section 8.1, okay? Section 8.1, there's a list of them, but you can ignore number 20. Okay. Questions? Those 19. Yep, that's it. There aren't any more. But if you look at some of those at the beginning, they're ones you wouldn't memorize, like the power rule. You wouldn't memorize those. Okay, let's check out your homework. Now, these were worksheets where things were all mixed together, so hopefully that kind of gave you a sense of, on the test, things will all be mixed up. I will be here after school today, so review session today, Monday and Tuesday, so if you're able to stay, you're welcome to do that. If you're unable to stay, I posted the Chapter 5 review thing that we'll do after school on Blackboard. Okay? The other thing I want to point out, so that you know it's there, next week we'll be coming up to an assignment where you'll have to do some practice for the test, for the AP test. So on Blackboard, I tried to go through my classroom. Maybe one of you guys know what this is. I tried to go through my AP classroom and distribute, just like I did earlier in the year. Remember how you got on and you did it? And I could see very quickly, like, who missed what problems and, like, how many missed a certain problem. It's really nice data for me. But now you have to get some kind of lockdown something on your computer before you can do that. So what I did instead, because I have to figure out what that is, because I asked someone they didn't know, so I have to try to go through a tech. But what I did is I just posted what I'm going to call Practice Test OWL. On your AP test, there are going to be 4 sections. There will be a multiple choice non-calculator. There will be a multiple choice calculator. There will be a free response calculator, free response non-calculator. So we'll eventually go through that entire test, but what you'll have to do is just get it from here, write on paper your work. And then I will give you next week like an answer sheet to put your final answers, and then I'll collect your final answers and work. But anyone that wants extra practice for the AP test, you do not have to buy a book. I will put some optional stuff on here as well. So as your practice, just like you would for the SAT, you want to practice for the AP test. Okay? Any questions? Or if school would be closed for any reason, I might assign parts of that. Okay, someone asked, well, what if we're out for a while? I don't have any days to play with to give you all the information for AP Calc so that you're ready for the May test. So I would have to go and find videos from last year and post those as assignments. Okay, but we'll see. So how was worksheet on page 53? That was okay, so let's go over any questions you had. And then if anyone wants to, I'll start after the Chapter 5 test, after school, if anyone wants to review for the AP test, I am willing to do whatever. If people want to come in and take a free response for 15 minutes and then score it, we can do that. So just let me know. Okay, what numbers on page 53 cause some issues? Yeah. 8 and 10. So 8 was asked earlier. So yeah. Number 8, gosh, when I look at that one, I start it by looking and saying U sub doesn't work. It looks like it might be arctan. But then I look at the top and I go, but wait, there's an arctan in the top. So maybe if I let U be the arctan, the derivative will work out to be the du. And that's what happened. But what was a little bit tough on number 8 was when you found the du, you had to do some significant algebra manipulation to get it to be 2 over 4 plus x squared dx. So you had to simplify it. Then it works out pretty nice into integrating 1/2 u, and then we get the answer. Questions on that one? Number 10, we'll look at next. And then the assignment that I have over the weekend, they're going to be book problems from section 8.1, which is just like section 5.7. It's just integration. We're just mixing it all up. And it's a little more mixed up in 8.1, so I like that. And then your big old free response, you're going to do another problem, your free response problem, and then get your cheat sheets together. So you should have cheat sheets done for all the chapters, right? Okay, because we did those before each test. So you want to make sure you get those together. If you didn't do one before a test, go back and do that. Those will be worth 20 points. So I'll look for really good cheat sheets. You want to make sure you have everything in there. I do mine too, and then we'll go over what we have in our cheat sheet so that if you forgot something, you can add it, but that's 20 points. And another thing, don't throw your AP stuff away yet as we finish it. We will have an AP burning. We won't burn anything, but we'll recycle it, okay? And I'll ask you for specific AP materials back because you can keep your packets, and if you take a calculus course, you keep the stuff that's going to help you, but there are going to be like your mega multiple choice packet. There are going to be things that you won't need. So I'll take those back for 20 points after the AP test. Okay, so don't throw that stuff away. All right, so number 10. This is a differential equation, so it's a whole lot easier to change y prime to dy dx, separate, and then integrate both sides. This one worked out real nice and to be the arctan. Then they wanted you to find if 2 comma pi is a point, what is the c value, and then what is the function. So I put pi in for y, I put 2 in for x, had to figure out the arctangent of 1, which was pi over 4, and then solve to get the c value of 7 pi over 8. So that was integrating, then using an initial condition to find out the value. Anything else from 53? The other ones went okay? Okay. It was set up pretty nice because I think it was like derivatives and then integrals. That's exactly what your test is going to be. 4 or 5 derivatives or 4 or 5 integrals, 1 inverse problem, and 1 sine arc tangent of -4/3, something like that. Okay, what about 55 and 56?
8.
Number 8. Oh, that one was asked. That is a great one because there will be a derivative problem on the test, I am sure, that is a variable to a variable. Do we have a formula? So what do? ln both sides. There's no formula, ln both sides. You can use implicit differentiation. Solve for y and put everything back in terms of x. That was a good one to ask about. What else on that page, on 55 and 56? Number 16. That was the other one that was asked in 4th period. So we're asking the same question. So I got to remember that for 9th period to see if they ask the same. Any other questions on 8? You'll multiply it to the other side, so it's going to be y times that entire quantity, and then you put y back in terms of x at the beginning. Yep.
13.
13, okay. So 13 and 16, I think I can fit both of them up here. 13 was integrating using arc sines. I let a be 5, u be 4x, so du was 4 dx. I had to balance with a 1/4, but I already had a 3/4 out there, and then I could get it. And 16, I'm going to assume just by looking at it that they want me to integrate 4 to the u. So I'm going to let u be the exponent, get the derivative, balance with a -1/6, the 2. And then when you integrate 4 to the u, remember when you integrate, the power rule, you always divide. So I think divide by ln of 4, and then multiply by 4 to the u plus c. All right, guys, so happy integrating. If you're staying today, I will see you later on today, 2 to 2:30.